Okay, good morning all. Am I audible to you? Yes, okay. Yes, so we were discussing WS policy last time, and that is from chapter number 7. I hope you are also referring to the book, those who are having, right? Chapter 6 and 7 we have followed in the second sessional phase. And let me just give you the roadmap for the third sessional phase before we begin. First of all, we will be finishing the topics of chapter 7, which are left. So a few topics like WS MEX, right? One of the standard that is used, Metadata Exchange, that will be finishing first. Then we'll be looking at WS Security, that provides the security across the various platforms, right? And then we'll be going with the next topic as WS Notification Framework. WS Notification is basically a standard to represent your publish and subscribe model, right? So how we can actually use that publish and subscribe model, right, practically. That is that concept. Then in the end of this chapter, we'll be looking at WS eventing, right? So actually notification and eventing, both are, you can say, representing the same concept, publisher and subscriber model, but they are owned by different organizations, or you can say they are designed by different organizations. One of them is designed by IBM, and the other one is designed by Microsoft, right? So notification and eventing will finish this chapter number 7. And then, as I discussed in my first lecture regarding the principles of SOA, right? So at least can you even tell me how many principles we are having in service-oriented architecture? Number 6, 7, 8, 9. Anyone remembers the exact number? It was 8, right? Okay, so chapter number 8 will be beginning once we finish with these 4 topics. In chapter 8, we will be covering the details of service-oriented principles, right? And then once we are done with that, before the third sessional, we will look at how the services can form multiple layers. Like an architecture has number of layers of services, right? So service layers would be our last topic before we finish this subject, right? So that is the roadmap for the third session. Chapter 7, remaining portion will complete. Chapter 8, and some portion I'll take from chapter 9 regarding the layers of services. Okay, fine. So let us start. Can you see the slide share? Is it visible to you? Yes. Okay. Thank you, Urjit. So I'll start with metadata exchange, right? So now you have enough experience of programming WCF, and we almost finished WCF in terms of lab, right? As well as in lectures as well, right? So in case of WCF, how do we exchange metadata? Can anyone tell me? So how Microsoft has implemented this concept? What have you experienced by programming WCF? You can just write down the name of the technique that you use for metadata exchange, or any method that you use for that. See, ultimately, you should be able to relate this theory with the practical, right? Otherwise, there is no meaning of studying all this theoretical concepts, right? We are studying theory over here, and you are studying practical implementation in the other portion. So that is how this subject is divided, right? So how do you access the metadata of a service? Or in other words, if I be more specific, how do we access the WSDL file in WCF? Yes, no one remembers? Using base address, correct, right? Using max endpoint. Yes, that is also possible, right? Correct, Prince. So that gives us only WSDL file. Yes or no? when I'm connecting to the max endpoint or when I'm using the base address, right? I am able to download only visual file, right? So what if I want to have the XSD schemas, or I want to have the policy, or if I want to have the complete service contract, right? In WCF, they've just implemented a part of this. That is, you can access the WSDL file using your service reference. Remember that concept? When you add your service reference, your WSDL file gets downloaded on the client side, right? So in theory, what is there and what Microsoft has taken out from it? That's what now you will be able to compare, right? After studying this. Okay. So basically, can I say that metadata is only WSDL? Yes or no? Metadata is only WSDL or not? No, right? That's correct, right? So metadata includes the WSDL. It also includes the schemas. Yes, because yes, correct, Urjit. Because we need to define the uh, type of the data that we are using, and the type of data we define in XSD schemas. You studied that in the first sessional phase, right? Next is policies, right? Just before the sessional, we have gone through policies. Policies are used to define the, you can say, rules, right? That every organization implements. So if you want to connect to, let us say, some company like Railco or TLS, first you have to look into the policy document, right? And then you can think whether I'm applicable to these policies or not. Okay. So metadata is three things: WSDL, XSDs, and policy. Okay. And what about contract? Can I say that contract is same as metadata? Again, one more question for you. Contract is same as metadata. You can also say service contract, right? Maybe. Okay. Anyone would like to answer no over here? I'll be happy to hear that. If anyone remembers, right? Okay, no issues. Metadata and contract, it includes interface. So yes, okay, okay. So in terms of WCF, you are answering, right, Priya? Yes. So in terms of WCF, yes, you are correct, right? But in terms of theory, what we have studied, contract is collection of these three, that is WSDL, XSD policy, plus legal documents. Remember that? Legal docs, right? Suppose you are using that service in illegal manner, right? So some actions might be taken, right? So I'll ask another question. Now answer that. Can I say that metadata information or metadata is a subset of contract? Metadata is a subset of contract? According to theory, don't think in terms of WCF, right? Because see, every vendor implements the concept in their own way, right? So we should not stick to only one framework, right? Okay. So what is the answer? Metadata is a subset of contract? The answer is yes, right? Because metadata has WSDL, schema, and policy, and contract has one extra thing, that is legal document. Is that clear to all? Right? Am I making sense with this? Yes. Okay. So the message that requester generates, right? Now let us look at the last line written over here. The message that the requester generates must be valid according to two things: WSDL of the provider. That means you should be calling an appropriate operation. You can't call an operation which is not defined, right, in the WSDL file. Next is policy, right? You have to follow the business policy of that company if you are using that particular service, right? So every time a requester has to check two things before generating a request message: WSDL and policy. Okay. So how this all things are maintained, right? Or what is the standard that represents this concept? And that is called WS MEX. I'm giving you the short form. The full form is WS Metadata Exchange, standard, or you can say specification, right? So that is the standard that we have, WS Metadata Exchange, right? So regardless of how much metadata a service makes available, we still need to retrieve this information, right? So WCF makes the WSDL public, right? Because they have implemented the metadata concept in that way. If you select any other framework, then that might be using some other technique, right? So implementation can be different, but ultimately we have to access that metadata. Can I call that service without accessing the metadata? A simple question. Can I invoke a service without having access to its metadata? See, I'm not being specific over here. I'm not asking that, or I'm not saying that without having WSDL, right? When I say metadata, you assume that WSDL is a part of that. The answer is no, right? So ultimately, a requester has to first get the metadata. Fine. So there are 4 ways of doing this, right? We know that we can also use UDDI, right? We have seen that concept. That is also a part of this 4 ways, right? So first option is we can manually locate by searching the published documents. So suppose if it is a weather service, or it is, you can say, currency conversion service or something like that, then that might already be available on web. They might have published that on their website or somewhere else, right? So we can simply search for it manually, right? And if we find that this is a good service, you will download its metadata and you will connect to that service, right? So that is manual location, right? Second is manually requesting it by contacting the provider entity. I hope you remember that concept, provider entity and provider agent. Which one of that is a web service? Provider entity or agent? Okay, entity is a web service or agent is a web service? Anyone else would like to answer? Provider entity is actually the organization that provides you the service, right? While agent is actually the web service. I hope now you can recall that, Dev and Priyank. Yes, right? So agent is the web service actually. So what we can do, if I know that a very good service exists that provides me my required functionality, so what I can do is I can contact the owner of that web service, right? That I want to use your web service and you provide me the metadata. So that is known as manual request. So I hope you are clear with the difference between first and second, right? Is it making sense? First and second point, both are manual. But in first case, we are searching it for public metadata, right? While in the second case, we already know that this kind of service exists, right? And we'll be requesting the owner of that service. Like, you know that a company like Railco is existing. So you will contact and request Railco that please provide me the metadata for your service, right? So that is manual approach. Now, as we are programmers, we would more prefer a programmatic approach, right? So there are 2 ways for accessing metadata programmatically. The first is we can programmatically retrieve via public service registry, which we know as UDDI, right? UDDI is just one way of implementing service registry. UDDI is just one way of implementing service registry. Fine. So if it is already public, right? And I hope you remember, if you want to access description from UDDI, do we have to first register our organization to the UDDI or not? Yes, right? We have to first get ourselves registered with the UDDI. Then you can search for available descriptions. That is the process, right? So everything will happen programmatically. You will register programmatically and you will be able to search programmatically, right? No human involved over here, except the, you can say, person who is, you can say, managing the WSDL files on the UDDI side, right? The last option is programmatically retrieving by interacting with the proprietary interface made available by provider entity, right? So in this case, what we are saying is, you know that a company like TLS has a local repository, right? So you contact that TLS company, and TLS company gives you the access to their local registry, and you programmatically retrieve, right, through that. Okay, is this making sense? Third and fourth, are you clear with the difference? Yes? Yes, sure. Programmatically retrieving means you know that a company like Railco exists, right? And Railco might have made its local registry available to you based on permission, right? If you have the permission to access the local registry of Railco, then you can directly connect to that registry of Railco and you can download the WSDL details. Yes, is that fine, Udit? Instead of searching through global, we are going for a local scope. Okay. But as you can see, the third option is marked as bold. Can you tell me why? Why the third option is marked as bold? We have seen all four options, right, for downloading the metadata. So why the third one is marked as bold? Okay, I'll ask in the other way. Does it seem that the third option is the most appropriate out of all? Most reliable. That's correct. Not practically possible other than that. Yes, you can say that, right? So under one condition, we can say that this is, you can say, most valid option. And the condition is everyone makes their service public. Yes or no? If everyone makes their service public, we can say that the third option would be the best one. Yes or no? I hope you are getting right. Yes. And registered with UDI. Correct, correct. Yes, you have to register. Right. Okay. So I'll again repeat, there are four ways of retrieving metadata, right? And we have seen all four, but one of them is, you can say, most appropriate, right? Okay. Now we'll go for the example, right? You can see this example. Service A is saying that I have heard of you, tell me more, right? And service B is saying that here you go, my life story, right? So which kind of approach is this? Which kind of approach is this? Can I say it is the mix of third and fourth? Yes or no? See, first, you might be going through a public registry, right? And you might get basic information regarding service B, right? And if you are further interested, you will contact service B that provide me more details, right? So service A is saying that I've heard of you, tell me more. And service B is giving you all details. So we can say 3 and 4, right? Yes, others, Urjit has agreed. I think, yes, Priyank. Okay. So this is the essence of metadata exchange specification, or you can say WSMEX, right? So let us go in detail of WSMEX. WSMEX is a specification that allows for a service requester to issue a standard request message. Everything is a standard, right? Remember, because we are studying SOA. And if you want SOA to be acceptable by multiple vendors, Microsoft, Oracle, and so on, right? Then we need standard. WSMEX gives you standard rules. Now, how you implement that, that is up to the framework, right? So this standard request will be asking for some or all meta information, right? Some or more. We'll also discuss this in detail. Why only some is required and why all is required. There are two cases. right? Related to a specific endpoint address, or you can say a specific service, in other words, right? So using MEX or WSMEX, we can issue a standard message to get the metadata. That is the essence, right? So what are the types of messages it supports, right? In theory, it supports total 5 messages, right? I've already I've mentioned 4 over here. Fifth one we'll see in the process, right? So in the theory of WSMEX, we have 4 types of messages: get WSDL, get schema, get policy, get metadata. That is the fourth one, right? I think the first 3 make sense, right? If you are just interested in getting the WSDL detail, you will fire a get WSDL request message. Now, will it be a request response MEP? Will it be a request response MEP? You have studied MEPs in you can say WCF also, right? So get WSDL will be a request response, right? Obviously, it won't be one way, right? You are requesting and you are getting the WSDL. Similarly, you are requesting the schema and you will get the schema file. Okay, same applies to the policy. Okay, then why do we have get metadata, right? So sometimes we are interested, or we have finalized that I'm going to, yes, all correct, Priyan. We have finalized that this is going to be my provider service, right? So I'll be sending a get metadata to get everything. Okay, so that is what is get metadata message. Okay, but that might be a issue over here. What do you think about the size of metadata? Will it be small? Yes or no? No, correct, right? So although you are interested in getting all metadata, the provider might be sending you the partial metadata. By partial, what do I mean is, some of the things like WSDL and schema might be sent as it is, but the policy document and all the documents might be sent as references. I hope you know reference. Reference means URL, right? You are not providing the actual document, you are providing a URL where that document is hosted. So yes, links. So do you think that this is a better approach to reduce the burden of transferring a lot of data? Right? Although requester has requested everything, right? But as a provider, maintain your network efficiency, we will not be sending everything, right? As in actual form. Some things you will be sending in actual form, and the others will be sent in terms of references. Okay, so get metadata not necessarily returns you all details. Is that point clear? Get metadata does not always return all details, right? Okay, it has to be request response, isn't it? Because you are requesting for metadata, so you'll be getting something in response, even if all of them are links, right? But a response will be there. So it will be, yes, we are also going to see this in, you can say, more detail. So it is request response again, right? So all 4 are request response, plus we have one more message, and that is called get request, right? And the corresponding pair of that is get response. I'll explain just after a few minutes what do we mean by this, right? So I think the first 3 messages are clear to you, right? Get WSDL gets the WSDL, get schema gets the schema, and get policy gets the policy. We need to go into detail of get metadata. That's what we'll look into now. So get metadata is a pair of messages, right? So a service requester can use Metadata Exchange to programmatically request available metadata. Okay. So for that, we have to issue a get metadata request message. Again, this is a standardized name, right? The frameworks like Microsoft or Java or Oracle might modify them, right? But in theory, it is known as get metadata request. Okay. This kicks off a standardized request response MEP, right? Resulting in delivery of get metadata response message, right? So it is a pair. Okay. Uh, it is also possible that response might be delayed. Is it possible or not? You might not get response immediately, right? What if that provider is busy serving some other requesters, right? Or what if the size of metadata is somewhat larger, so it would take time to gather that, right? So that is why uh, it will not be immediate request response, but ultimately it will be request and response, right? Finally. Okay. So this is the diagram of that. Service requester is sending the get metadata request message, and provider is sending the response. Okay. And what it can include? Definitely, it includes the WSDL because that is the first thing that you are interested in. Then you might send XSD as it is, or you might be sending references of XSD. That depends upon the provider's decision, right? Policy documents is usually very bulky, right? Policy can have 50, 100, 200 pages, right? So you would not like to embed that in your SOAP message, right? I hope you agree to this because rules are written in bulk, right? So that is why for policy, ideally the provider would be sending the address, okay, or you can say the reference, okay. So now the question is, if you receive some references, if you have received a reference of XSD schema, or if you have received a reference of policy document, can we access that by using that link directly, right? This standard says that we should not access it directly. So for that purpose, what I wrote over here, yes, what I wrote earlier, get request and get response. One more MEP will take place. Suppose I want the actual policy document. I will fire a get request message. Remember, earlier which message was fired? First time, which message was fired? Get metadata request. Right? Correct, correct. And then we got get metadata response. Message number 2. Message number 3 would be what? Get request. And obviously, what would be the fourth message? Get response, right? So actually, it kicks off two messages, two pair of messages, ideally, right? Whenever you implement that in theoretical concepts, right? Okay. So that is written over here in this slide. Is that making sense? What I explained? I hope the basics are clear so that I can go with the theory. Yes. Okay. Get metadata response may contain references for some meta information. If requester needs the actual information, it can use get request and get response messages, right? So get request will be sent from requester to provider and get response will be sent from provider to requester, right? So that's how we follow this, right? So you can see this, right? Actually, this is message number 3 and 4, but as this is a different diagram, so that's why the author has provided 1 and 2 over here, right? So in message number 1, what we are asking is, I want the policy document of this URL, right? URL I'll be providing and I'll be getting the actual policy document in the message, okay? So can I say that we are decoupling basic metadata exchange with detailed metadata exchange over here? We are decoupling the basic metadata with detailed or you can say detailed metadata. By basic, what do I mean is WSDL, right? Ideally, we are first interested in WSDL, right? Isn't it? If WSDL is fine, we'll look at the policy, right? We'll look at the rules that that organization enforces on us, right? Then if I want to follow the rules, I'll download the policy. Make sense or not? This is the actual approach, right? That we have to follow, right? Okay. So this is 2 pairs of messages. Same for schema. Okay. Yes, if schema files are sent as reference, then we can say same will happen for schema. But ideally, if you have 2 or 3 schema files, then that can be sent in the get metadata response message itself, right? Unnecessarily, we would not burden the network, right? But if there are 15 or 20 schema files, then definitely we would be sending references. Yes, Surjit? It depends upon number of files that you are having, right? The bulk, right? That is what matters over here. Okay. Now the next point, what I discussed above, or you can say over here, that gives us a conclusion, and that is known as selective retrieval of metadata, right? Meta documents describing the service with comprehensive interface. Comprehensive interface means you are having lot of operations, right? Let us say you are having a service that provides us 20 or 25 operations, right? A single service provides us those many operations. So in that case, the meta information will also be huge in size. Okay. So it does not make sense in sending everything, okay, in the initial stage. And that is why the concept that is used over here is called selective retrieval. Selective retrieval means although requester will be you can say requesting for everything, right? But get metadata will send only essential information. And by essential, what do I mean is again the only WSDL file. You might not be sending the schemas as it is initially, right? Based on the next request, you will be sending the further details, okay? So that we can reduce the burden, right? And we can reduce the delay as well, okay? It is up to the requester to determine which actual information is required, right? So we are actually shifting the burden. Provider is not giving everything. Okay, provider is saying that, okay, you need this much, but I'll provide only subset of that. Now you decide what else you want from this. Okay, so this is known as selective retrieval. Can I say that selective retrieval will make the SOAP message exchange efficient? Or it will avoid unnecessary transmission of data? In other words, it will avoid unnecessary transmission of data, right? That's correct, right? So always we should be selective in terms of retrieval of metadata, right? So this is the concept of metadata exchange, right? Again, I'm repeating, this is in terms of theory. Every framework has implemented this metadata exchange standard in their own way. In WCF, they've implemented this in terms of max endpoint. Through max endpoint, you can access this meta information, right? While if you are using some other framework, they might be using some other technology, right? So it depends, but the concept is this. Okay, if you know the concept, you can easily learn the framework, right? That is the you can say point in covering all these things. Fine. Okay. Next point, we still have one point to discuss in metadata exchange, that is description discovery. Okay. How do we perform service description discovery? Using which entity? UDDI, correct. Universal Description, Discovery and Integration. Remember the full form? Universal Description, Discovery and Integration, right? So now the question is where the UDDI will come into picture, right? So ideally, as we said that third option is appropriate. Which was the third option? This one. Programmatically retrieving via public registry, right? So first you will be contacting the public UDDI, or you can say public registry, right? And then if you are interested in knowing more about that service, I'll repeat, first you will contact the UDDI, okay? And then if you are interested in knowing more details, further details, then you will kick off the get metadata exchange messages. Yes or no? Yes, surely I'll repeat. First, we will go through UDDI. UDDI will give us basic information, right? Because as you know, if you remember, UDDI may store WSDL files directly, or it can also store references of the WSDL. Remember that concept, right? To have less burden on the UDDI, ideally, we would say that references would be better, right? So that the size of UDDI is less. Yes or no? Right? So only basic information would be kept in UDDI. Okay. Once you have the basic information, then you can contact the respective service, right? And you will exchange the metadata directly by contacting that service. Are you getting this? So UDDI will just provide you the, you can say start, right? From that start, you will be able to get the basic information. And once you got the basic information, this actually happens. I showed you this, right? Now this makes sense, right? I have heard of you. Tell me more, right? And from where you will hear of that service? From UDDI, ideally, right? Is this getting clear? Right? So, metadata exchange and description discovery are related. Okay. So, which happens first? Description discovery or metadata exchange? If you have listened what I said in past 2 minutes, can you answer that? Description discovery happens first, correct? Right? Yes. Right? So that is what is the relation, right? What is the relation between metadata exchange and description discovery? Let us go through that now. It is important to note that metadata exchange does not really help requester to discover the provider, right? Discover means I should have the basic knowledge. That basic knowledge is not the job of metadata exchange. Metadata exchange gives you details, basics you have to obtain. And we will be able to obtain those basics from UDDI. Clear with that mapping now? Right? So, service registries such as UDDI, right, can be used to discover descriptions that meet the criteria. Okay. Hence, registries can be used in conjunction with metadata exchange messages. So first you go through registry and then you go for metadata exchange. That is what is the real world scenario. That's what it takes place, right? Let us now go through that, right? So essentially, a requester could first query a public registry. Step number one. Step number one is go through public registry to get the endpoint address of any web service candidate that can seem appropriate to us. Right? Suppose I'm searching for an accounting service. So UDDI has a list of 50 accounting services. So I'll go through that list. I'll find out with the basic information that this service, or let us say, I'll shortlist out of 50, 3 candidates. Right? This is what happens. You will select, let us say, 3 out of 50. And now, what you will be doing is, you will be sending get metadata request to those 3 services. Making sense? That will be step number 2. Step number 1, I'll repeat. You will first go through UDDI to find potential candidates, potential providers. Now you shortlist that these 3 seems best, right? You would not be able to decide only one because sometimes these service interfaces might be looking similar, right? So we'll decide or shortlist 3 or 4. Then I'll be sending get metadata exchange or get metadata request message to 3 of those services, right? So, or you can say all 3 services. And based on the get metadata response that you get, right, you will decide 1 out of those 3. Are you getting this process? Right? Okay. So let us go for the second point. The same requester could then employ metadata exchange to contact each candidate, right? Those 3 that we have decided, right? And request associated metadata documents. This would give service requester more information to better assess which provider it should be working with. And finally, Finally, if you have come up with the final name, right? That is, I'll be going with service 1. Okay, 2 and 3 are not useful to me. So then you will start communicating with service 1, right? So we have to do all these things due to one principle, which is that why we are doing or taking such burden, right? Even for studying as well as for remembering the concepts, right? Because we have to satisfy one principle, which I have been saying since my first lecture. Why? Or which principle we are focusing on? Come on, this should be easy. Yes, yes, isn't it? Loose coupling, right? See, we can't bind the requester with provider from the first step, right? We want requester to search for available providers and then connect to the appropriate provider. Can I say that we are having loose coupling by doing this, right? So loose coupling is the, you can say, main issue that we need to manage, right? When we are providing or when we are using this, okay? The last point regarding metadata exchange is version control, right? It is obvious that your service will undergo changes, isn't it? Right? Will it remain same for 1 or 2 years? Do you think that your client will be, so satisfied with your implementation? No, right? Obviously, right? So they want some changes, right? So as soon as you make changes, your metadata will change, yes or no? Isn't it? Metadata is going to change, right? So the question that remains is, should we maintain the previous versions of metadata as well, or should we throw it away? What do you think? Should we maintain? Yes, we have to keep it, right? Because it is possible that only a new client require that new functionality. Your old clients might still be satisfied with your old interface, isn't it? Right? This is a real world situation, right? Your old clients do not like changes, but whenever you get a new client, they will be interested in getting the changes done, right? So that is known as version control. Yes, maintain means updating. No, you won't update. See, you have to maintain the old version, plus you have to keep the new version as well and support both the clients. That is the challenge, right? So that is known as version control. I think in software engineering also, you have seen the basics of this. Configuration management, remember that concept? Again, you will be appearing for interviews very soon, right? Maybe in your next semester. So you should know these terms, right? Configuration management is about managing the versions, right? At least anyone remembers that term? Yes. So just go through those basics, right? Because your interviewers might be interested in knowing whether you know all the concepts or not, right? So this is, you can say version control is a part of configuration management, right? In any organization, okay? And for that, we have a standard called CMM, right? Remember that name? CMMI or something like that. That was the name. So if not, you can just refresh, right? Okay. So as the service evolve, the nature and scope of functionality can undergo alterations, right? Nature and scope. Nature means you might be changing that signature, right? Sometimes you want to add some extra parameters or you want to remove some unnecessary parameters, right? So that is nature. And scope means you are adding more operations, right? You are adding more operations. So this can lead to new versions of wisdom, schema, or policy. See, policy can also be versioned. Why? Because when you came into the market, you defined rules at 1. Now, when you remain in the market for 2 or 3 years, you decide to extend your rule set, right? So policy documents can also be versioned, right? XSDs are obviously versioned because if you change your data, then the data's definition has to change, right? So service-oriented application that supports metadata exchange can allow the requester to retrieve the latest service contract. Okay, so it should not be like that, that requester has been given metadata once and they cannot contact you again for getting metadata. They can contact you at any point of time, right? Uh, to just get the knowledge whether the metadata has been updated or not. Okay, so we should be able to let the requester have the latest metadata if they require. Okay, and as often as they require. Okay, so this is not that easy, right? We have to maintain multiple versions. We have to provide metadata. Plus, we have to, you can say, provide metadata as and when required. Okay. So ultimately, the designer of architecture has to be very critical in all these concepts. Okay. Fine. So I hope you are clear with the basics now. What is MEX as a standard, right? WSMEX, right, is the standard which we have covered. Let us summarize. What are the principles or the concepts that MEX targets? MEX targets interoperability, obviously, right? Loose coupling, I'm not discussing once again because loose coupling is the essence of this, right? Interoperability, why? Because, see, we have to exchange the metadata independent of the platform, isn't it? No matter on which platform that service has been implemented, right? We want metadata in a standard way, right? Again, MEX is an XML based standard, right? So if you understand XML, you can easily exchange metadata, right? So I think you remember that your app.config file is which kind of file that is getting generated once you add your service reference. On the client side, app.config is getting generated, and the type of that file is, can I say again XML? Yes, right? So can I say it is again platform independent? In other words, does not matter, right? From where you are getting. Okay. Reusability, very important, right? If you make your service public, right, it is going to be reusable. Yes or no? Because that is why you are making it public, right? So that everyone can use it. Okay. So again, metadata exchange is related with reusability principle, right? Discoverability, very obvious again. Metadata is possible to access, or you can say we can access metadata only if it is discoverable. Yes or no? We can access metadata only if it is discoverable. Otherwise, if it is made private, we cannot access it directly, right? And by having all these things, we can say that quality of service improves, right? We are not letting everyone request the metadata at random point of time. We are using a standard for that, right? So the quality of service will definitely improve. Okay, let us go into the arrows. Metadata exchange is enabled by standardizing the messages. Is this clear? First arrow, top left. For metadata exchange, we have to use messages, right? And they have to be standardized. Okay. Metadata exchange uses addressing, yes or no? Because ultimately you have to know the endpoint address, right? Where that service is there. So it uses addressing, right? We can say that. Okay. Bottom left, metadata exchange standardizes sharing of metadata for web services. Obvious, yes or no? We are using a standard, so everything is standardized, right? Metadata exchange standardizes the retrieval of policies. Again, very obvious, because your get metadata request message can provide you links for the policy, but you can send a get request message in a standard way to get the policy document. Okay. So MEX is a very, very important standard. Do you agree with this, at least after having discussion of around approximately 1 hour, right? 10 minutes are remaining. So this is a very, very important specification, and every framework has implemented this in their own way, right? So no matter what framework you are learning, right, but you should know the basics, right? I hope I have made that concept clear, right? Okay, let us now go for the example, right? So from the case study, I've taken the example. Suppose you know that account service exists, right? From UDDI, you have found that there is an accounts payable service. Okay. So then you will be sending get metadata request message. But obviously, that message would be interrupted by the load balancer in between. Remember that service? Load balancer? It will not directly send it, right? Whenever there is less load on the server, you will be sending that message. And then accounts payable is sending the direct reply. Can you see that? The reply is not going through load balancer. I hope it makes sense, right? It is direct communication, right? And then if you are satisfied with the metadata that you have received, right? Suppose all the documents have been sent in original, no reference is sent, then you will finally generate a message for invoice submission, right? And again, invoice submission will be going through the load balancer, and then it will read the accounts payable service. Okay. So before we send invoice submission message, at least two messages will be exchanged, right? Why I'm saying at least two? Because there can be two more. Which two we can have further? Get request and get response. Correct. Right? Correct. Very good. Right? So this is how you can remember. Right? Before you send your first message, we have to first get metadata. And in terms of WCF, you are adding your service reference, and that service reference is the step number 1 that you are doing. Make sense? Adding service reference is the step number 1 that you are doing, right? And then in step number 2, you are directly calling the service. Okay, so they have automated this. Microsoft has automated this, right? In one sense. Okay, fine. So this is the summary. As always, you can go through that later. Now I am going for security. Fine. So WS security is a set of standards. It is not a single specification. It is a set of 3 specifications. WS security, XML signature, that focuses on appending a digital signature with your SOAP message. And the third is XML encryption, that ensures the secrecy of your message, right? In nowadays situation, these standards are absolutely necessary, right? So this is a family of extensions. Remember, it has three core specifications. There are many more, right? I'll be discussing only 3: WS security, XML signature, and XML encryption. Okay, let us begin with the basics. So in terms of web services for SOA, we need to satisfy 5 requirements for security. Okay, first is identity, second is authentication, third is authorization, fourth confidentiality, and fifth is integrity. Let us understand from the name itself, and then we'll go into detail. Identity, right? Suppose you are receiving a message from an unknown service, and that is going to happen in SOA because we are having loosely coupled concept, right? So ultimately, whenever you are getting an invoice from someone, right, you don't know that service. So should that message contain some identification information of the sender? Yes, right? The request message that you are getting must have some identity information. Yes, at least the source information, so that the provider can actually go to that URL and find out this is not an imposter, right? In current situation, this is very important, right? That is known as identity, right? Second is authentication. Now, only identity might not be sufficient, right? See, you say that I belong to this company TLS, right? Will that be sufficient? Will you trust that service? If you have a header that says that the owner of this service is TLS or Railco, Will that be sufficient? No, right? We need a proof, at least we need a proof, right? So identity has to be sent, plus you need to send a proof. And as a proof, we can send a URL of the web service from where it is originated, or you can send the website address of the company at least, isn't it? Right? So that you can go through that website and you can verify whether it is a valid request or not, right? Okay. So this is called authentication. You validate that the proof is actually valid or not, right? That is authentication. Now, once you are authenticated, yes, it checks identity. Yes, yes, Urjit. So actually, identity is a collection of two things. It provides you basic introduction plus some proof. We'll see that in detail, not possibly today, but in next class, that is tomorrow, right? So we need to send basic information plus some proof that serves as an identity. And authentication has to be done by provider, isn't it? Provider has to authenticate that is this proof valid or not. Yes? Do you agree with this? Okay. Next is authorization. So you have identified that this is a valid requester, right? But will you let that requester access every resource on your side? Obviously not, right? Because there are many services under your umbrella, right? So next task is to check authorization. What services your requester is allowed to access, right? Is it allowed to access only one service, or it is having a global pass and it can access any service on your side? Are you getting this or not? Yes. So this is known as what? Authorization. Authorization means you decide the access rights. Okay. What are the access rights that requester can have? Okay. Fine. Next is confidentiality. Right? Confidentiality means nobody should have looked into the message. Right? Message is going to travel through multiple hops, right? Multiple intermediary services. So we want to make sure that it has not been read by someone. Okay, are you getting this? That is confidentiality. And integrity ensures that the content has not been modified. Right? Content has not been modified. In case of transactions, right? This last two requirements are absolutely necessary. Do you agree with this? Right? Yes. Is this making sense, right? So if you want to have web services implemented in a secured manner, these are the 5 requirements we have to fulfill. Okay. Or at least you can say these are the basic requirements we have to fulfill. I'll again go through all 5 before we finish. Identity. Identity has to be claimed by the requester. Right? Identity has to be claimed by the requester. Then authentication has to be done by provider based on the proof. Right? Okay. By maintaining first 3, last 2 will be covered. Not necessarily Urjit, because what if your message is not encrypted, right? And you can generate a false claim also, isn't it? Can't you generate a false proof? If you are a real imposter service, you can generate a false proof, right? So we would not like to take any chances, right? I hope you agree to this. If it is a banking based solution, right? Yes, yes. So that is why. This is actually a set of standards. WS security is not a single standard, right? Okay. Then we have authorization that describes or that decides the rights given to that service. And finally, the encryption and all those concepts will be covered in confidentiality and integrity. So tomorrow I'll start in more detail these concepts, right? And then we'll see some case study example. Okay. Let us end this session for today. Thank you. Have a nice day ahead.
Hello everyone. So in the last session we have gone through the first example of push down automata. So let me share the slide with you, what we have done in the last session. So let us quickly recall in 5 minutes what we have done, because otherwise you cannot understand what is